Hi, it's Terry Dennery of the MathWorks. So yeah, I decided to do one more video, and it's here where I'm going to really say that what we've been doing in these previous three videos really has incredible relevance. And one example would be, it's essentially the approach for doing a flight simulation, especially our choice to do a vertical kind of transition. And so, anyways, I got this cool little aircraft right here. And you'll see that I apply the controls and the forces and the thrusters of this thing will basically allow it to transition again from 0 to 5 meters. Okay, and again, it's that same format of the model, F in and PVA out. And what I liked about this example was it required a little bit more elaboration, right? And so what I mean by that is that once we get in here, we're doing a little bit more with it, right? So that force is coming in. It turns out there are 4 thrusters, right? And we take that force and divide it by very, I'll say, very simple approach. Not necessarily the right approach, but probably a good place to start is divide it by 4 and allow all 4 thrusters to apply that same load, right? And the reason we can get away with it is because we chose to do this, and then we did put in that vertical constraint. So anyways, this is intended to be a kind of a quick video, and so I just want to kind of reveal kind of on the SimWise side that we got the 2 rear thrusters right there. And if you look at this in wireframe, you'll see there are 2 forward thrusters, right? And that's basically it. And I'll kind of leave this by switching to what we call a 6 DOF count. I think if I type in 6, yes, 6 DOF join. There it is. All right, and this is going to allow it to move in any direction. Again, this is a 3-dimensional tool, right? And you'll see that I made my positional measurements using a different approach, and it's essentially kind of in the world reference frame, kind of making a direct, I'll call it measurement of the body position of the fuselage itself, right? Main point here, and you kind of see in the image on the block, is that this is one that will allow it to move in all directions. And we'll go back here, and we'll reset. We'll run it from here. And who knows, it might do okay for 0 to 5 meters, but no, not at all. Okay, and as we kind of move through this, actually, here's one last kind of look at it. So let's undo, undo, undo until we get back to here. All right, and we'll delete that. And so the additional measurement we're going to make this time is going to be a total torque. Actually, let's do a constraint torque. All right, and we'll just kind of, let's just put in a PS Simulink converter. Let's put in a scope. And I think that this is a 3-dimensional signal, so it'll just all kind of show up in one scope here. All right, and so I kind of set it up so it goes up and down again, so we'll see it go vertically successfully this time. And the whole importance of putting in this constraint is allowing it to account for the torques that are required to keep it, kind of vertically actuated. And in a way, that's kind of an important part of what like flight controls do. Make it look a little bit more like an airplane again. Is that the thrusters that are kind of operating kind of in the front, the load, or called the gravitational force, that's pulling it down through its center of mass, and that the thrusters that are operating in the back, they really need to be determined. They need to be calculated. So not only do they add up to the lift forces that we need, but also that they sum to a 0 moment. And one way of thinking of it is take the moments with regard to the center of mass through which the gravitational force will act, and make sure that those moments add up to 0. And so flight controls and things like that, do that for vehicles like this. And definitely really interested in this kind of general shape and kind of including airfoil forces and all kinds of stuff. And so this might lead into kind of the next series I'm going to do. And I like the idea of a project like this where we'll do flight controls for a vertical takeoff, but also a vehicle that will transition into normal, I'll call fixed wing, flights or flight controls. So, anyways, all this stuff I think is super important. Hope you like this video. Thank you.